Take a look at this. A highway bridge, built less than 50 years ago, already showing cracks, rust, and signs of decay. Now look at this. The Pantheon in Rome. Its dome is the largest unreinforced concrete dome in the world, and it has stood, perfectly intact, for over 1900 years. What is going on here? Modern concrete, the stuff we use to build our cities, has a lifespan of about 50 to 100 years if we're lucky. Roman concrete has lasted for over 2 millennia. For centuries, we just chalked it up to luck or some lost recipe that vanished with the empire. We saw structures like the Colosseum still standing proud, while buildings from the 1970s are literally crumbling. How did they do it? The secret was buried for thousands of years, and the answer was finally unearthed not in some ancient text, but at a construction site in Pompeii in 2026. This discovery didn't just solve an old mystery. It's about to revolutionize how we build everything. Scientists examining ancient Roman mortar found something they never expected. Tiny bright white chunks scattered throughout the mixture. For years, these were dismissed as sloppy mixing. Turns out these little white bits called lime clasts are the key to everything. See, when a tiny crack forms in Roman concrete and water seeps in, it interacts with these lime clasts. This triggers a chemical reaction. The lime recrystallizes, filling the crack and effectively healing the concrete from the inside out. It's self-healing concrete. The Romans didn't just build structures. They built structures that could repair themselves. So, why don't we use this amazing recipe today? Well, we're starting to... But there's a catch. This hot mixing process, using quicklime, is way more volatile and dangerous than modern methods. Imagine trying to manage that on a massive modern construction site with today's safety standards. It's a huge challenge. But researchers are working on it, trying to create a safe modern version of this ancient supermaterial. If they succeed, we could be looking at buildings that last for centuries, bridges that don't need constant repair, and even infrastructure that can help us fight climate change by absorbing CO2 as it heals. The secret to our future might just have been waiting for us, buried in the past. For the longest time, we thought we knew their secret, a special volcanic ash called pozzolana. But it turns out there was another piece to the puzzle, a hidden ingredient that scientists dismissed for decades as just a mistake. If you look closely at a cross-section of Roman concrete, you'll see these little white chunks scattered throughout. They're called lime clasts. For years, historians and engineers believed these were signs of sloppy work. They figured the Roman builders were just bad at mixing their materials, leaving behind unmixed clumps of lime. It's like finding a pocket of dry flour in your pancake batter, a clear sign you didn't whisk it well enough. This sloppy mixing theory was the accepted explanation for a very long time. It made sense, right? But it was completely wrong. A team of researchers from MIT and other institutions decided to take a much closer look at these mysterious white specks. Using advanced imaging and chemical analysis techniques, they discovered something incredible. These lime clasts weren't a mistake at all. They were intentionally created and were, in fact, the key to the concrete's incredible longevity and self-healing properties. So, how did it work? The Romans weren't just mixing lime, water, and volcanic ash like we would today. They were using a process now called hot mixing. Instead of using slaked lime, but lime, which is lime already mixed with water, they used its more reactive and frankly more dangerous precursor, quicklime. They would mix this quicklime directly with the pozzolana and other aggregates at extremely high temperatures. This process created those little white chunks of lime clasts. And here's the genius part. When a tiny crack forms in the concrete over time, say, from a small earthquake or just general wear and tear and rainwater seeps in, it finds its way to one of these lime clasts. The water reacts with the lime, creating a calcium-rich solution that flows into the crack. This solution then recrystallizes as calcium carbonate, effectively sealing the crack from the inside out. The concrete literally heals itself. It's a brilliant built-in repair mechanism that has kept these structures strong for millennia. This discovery completely changes our understanding of Roman engineering. They weren't sloppy builders. They were master chemists who had perfected a recipe for a smart material 2,000 years before we even had a name for it. It's a mind-blowing example of ancient wisdom that we're only just beginning to rediscover. Have you ever wondered why ancient Roman structures like the Colosseum or the Pantheon are still standing after 2,000 years? We build something today, and it feels like it starts crumbling in just a few decades. What was their secret? For a long time, historians and scientists were puzzled by these mysterious little white specks found embedded in Roman concrete. They called them limeclasts. For years, the common belief was that these were just signs of sloppy mixing or poor quality raw materials. It seemed like a flaw, an imperfection. But what if that flaw was actually the secret to their incredible longevity? Recent research has turned this old idea completely on its head. Scientists discovered that these little white chunks are not a mistake at all. They're a key ingredient, intentionally added. They are highly reactive bits of lime, and they give the concrete an extraordinary ability: the power to heal itself. That's right, self-healing concrete. Think about how that works. Over time, tiny cracks inevitably form in any concrete structure due to weather or ground shifts. In modern concrete, water gets into these cracks, freezes, expands, and makes the cracks bigger and bigger, eventually leading to structural failure. But with Roman concrete, something magical happens. When rainwater seeps into one of these tiny cracks, it eventually reaches one of those white limeclasts. This triggers a chemical reaction. The water dissolves the lime, creating a calcium-rich solution that flows through the crack. Then, as it dries, it recrystallizes into calcium carbonate, effectively gluing the crack shut from the inside out. The structure automatically repairs its own damage, preventing small cracks from becoming big problems. It's almost like the building has its own biological immune system, healing its own wounds whenever it gets injured. This isn't just about preserving the past. This discovery could revolutionize how we build in the future, creating more durable and sustainable structures. So, the next time you see an ancient Roman ruin, remember you're not just looking at old stones. You're looking at a brilliant piece of ancient engineering that's still teaching us new tricks. It sounds like magic, but the secret lies in a special recipe, a recipe for eternity. The star ingredient? Pozzolana. This fine volcanic ash, sourced from the mighty Mount Vesuvius, was the key to their architectural genius. Unlike modern concrete, which is essentially just a paste of cement, water, and aggregates that hardens over time, the Roman recipe was far more dynamic. They would mix this pozzolana with lime and volcanic rocks. Now here's where it gets really clever. They didn't just mix it cold. They used a hot mixing technique, combining quicklime with the pozzolana and water, which created an incredibly high-temperature, steaming hot mortar. This process wasn't just for show. It triggered unique chemical reactions that gave the final product its legendary durability. But the true genius of Roman concrete is revealed when you add water, specifically seawater. Imagine building a harbor. For us, salt water is the enemy. It corrodes the steel rebar and breaks down the concrete. For the Romans, it was an ally. When seawater seeped into the tiny cracks of their underwater structures, it reacted with the pozzolana and lime. This reaction formed new interlocking crystals, like aluminous tobermorite and philipsite. Think about that for a second. The very thing that destroys our modern marine structures actually made Roman concrete stronger. The constant pounding of the waves didn't weaken their harbors. It healed them. It's a self-repairing material, created 2 millennia ago. The Romans didn't just build for their time. They engineered for eternity, creating structures that grew stronger with age, almost as if they were alive. It's an incredible testament to their ingenuity, turning a violent force of nature into the ultimate construction material. Imagine if we started using these Roman techniques today. We could construct buildings, bridges, and entire cities designed not just to stand for 100 years, but for thousands. Think about the incredible reduction in waste and resources. We wouldn't need to constantly repair and rebuild our infrastructure. This isn't just about building things that last. It's about building a more sustainable future. The production of modern cement is a huge source of carbon emissions, contributing significantly to climate change. By adopting this ancient, self-healing concrete technology, we could drastically cut down our carbon footprint. The Romans, without even knowing it, created a formula that is not only incredibly durable but also far more environmentally friendly than our own. This journey back to ancient Rome has shown us something profound. We often look to the future for innovation, for the next big technological leap. But sometimes, the most revolutionary ideas are buried in the past, waiting to be rediscovered. The Romans weren't just building for their time. They were building for eternity. Their ingenuity with materials, their understanding of chemistry and geology, it's a powerful lesson. It forces us to reconsider what we value in construction. Is it speed and low initial cost, or is it longevity and sustainability? The evidence is clear. The foundations of the past may just be the solution for our future. We have the science to understand why it worked, and we have the technology to replicate and even improve upon it. It's a bridge across millennia, a piece of wisdom from our ancestors that could help us solve one of the biggest challenges of our time. It's a truly humbling and inspiring thought. If you found this discovery as mind-blowing as I did, hit that like button to let us know. And get ready because our next video takes us deep beneath the waves to the sunken ruins of ancient Egypt. You definitely don't want to miss it, so make sure you're subscribed. Thanks for watching, and see you on the next adventure.